everybody. Today we are going to be looking at this really cool and very quick algebra problem. And the thing that makes it quite interesting to me is it seems like we don't have enough information, but it turns out actually we do. So what is the problem? Well, the problem is that you have a big semicircle and you have two smaller semicircles. And what you know is that the perpendicular separator of them has a height 8. And that is all you are given. You are not told the radii of any of these shapes. And what you're expected to work out is this area here, this blue area that I'm just going to highlight now. So as with all problems, if you want to have a go now, just pause the video, see if you can work it out on your own. Alright, welcome back if you did pause. So first things first, let's do a bit of algebra on this. Okay. So we're going to call the diameter of the bigger one A and the smaller one B. And then we're going to call the diameter of both of them put together A plus B. No surprises there. Now the blue area is going to be the larger semicircle's area, take away the two smaller semicircles. So let's just try and write this out in algebra, and then you'll see how this works. So what's the area of the big semicircle? Well, it's going to be pi r squared. Now the radius is going to be a plus b over 2, because that's the diameter squared. And then because it's a semicircle, we divide by 2. Now, likewise, it's going to be a semicircle. It's pi over 2 times a over 2 squared. We're dividing by 2 again because it's those diameters that I've drawn. And then pi over 2 b over 2 all squared. Now there's a bunch of factorization that we can do. We can take out all of those over 2's in the fractions. So we're going to get pi over 2 times, this will be a plus b squared over 4 minus pi to a squared over 4 minus pi over 2 b squared over 4. As you can see, these over 4's and the pi over 2 can all come out as pi over 8, and we are left with a plus b squared minus a squared minus b squared. Expand out that first one, pi over 8 times by a squared. Let's zoom in a little bit. A squared plus 2ab plus b squared. I think you can see where this is going now. These things here are going to cancel. A squared with a minus a squared, b squared with a minus b squared. And what are we going to end up with? End up with a much simpler expression. Let me just give myself some more space. And we're going to be left with pi over 8 times 2ab, which just becomes pi over 4 times ab. Now, this is definitely a lot simpler, but there is a problem here. We still don't know what a or b are. So how could we possibly know what their product is? Let's go back to the top. This could be any possible triangle. Sorry, any possible semicircle. And we're not given A or B, and we're given no sort of hint as to how to find them. So let's look at the second bit where we can actually work out what A, B is. So we don't know what A and B are separately, but maybe there's a way to find their product. Let's go back to the original picture, and let's see if we can work out something else. So let's just try and work out what we know. Well, these are right angle triangles. That's good to know. Let's draw them in. That's one right angle triangle, and that's another. However, there's a third right angle triangle hiding in plain sight. Now, this is just a fact from circle theorems in geometry, is that a diameter the two endpoints of a diameter joined to any other point on the circumference always makes a right angle triangle. Once you know that, you're going to get another right angle triangle. So in fact, we have 3. So let's start work on these 2 smaller ones, this one and this one, and then we're going to build up to this one. And let's just write down what we find. We found some new information. Let's see where it takes us. So this one, this side is going to have square roots of b squared plus 8 squared. This side here is going to have size a squared plus 8 squared. And now, let me just make this a bit easier to see. I've got this right angle triangle where this is b squared plus 8 squared, and this is a squared plus 8 squared. And now we know that this length here is a plus b squared, right? Because the a plus b is here. Now, sorry, that length there is a plus b, I should say. We're going to square it later. Now, for Pythagoras' theorem, we're just going to square all the sides and equate the sum to the hypotenuse squared. So you're going to end up with a squared plus 8 squared plus b squared plus 8 squared equals a plus b all squared. So this becomes 64 plus b squared plus 64. This, of course, becomes a squared. We've already expanded it out once in this problem. And we're going to get out my big red cancelling pen. Again, let's cancel these from both sides. And what do we find? We find that 128, 64 plus 64, equals 2ab. So ab equals 64. Now this is very, very interesting because although we still don't know what a and b are, we now know their product. So if you remember the first part, we found that the area of the blue area is pi over 4 times by AB. And now we know what AB is. So we get pi over 4 times by 64, and the answer is 16 pi, which I think is pretty cool. Now, one of the things I find quite interesting about this is that this is completely irrespective of the size of the circle or the semicircle, as long as it has a radius greater than or equal to 8. Okay? I'm going to include a link to a little GeoGebra and like thing that you can play with that will demonstrate this, and you can see actually even when you make the circle, the semicircles bigger, the area stays approximately the same. It's quite hard to see for some values, but as you play around with it, you will see. So I'm just going to leave you with one more problem if you've enjoyed this. Oh, that is not the problem I wanted. Here we go. So the problem for you is, what if we extend this? What if we have a circle and I tell you, okay, let's just draw the diameter. Now imagine I tell you that the height, let's just take the number from before, is 8. And let me imagine I give you another height, right, and this is 10. And then I tell you that there are circles. Okay, that's not quite a circle, but you get the idea. Circles filling this. Okay, that was truly terrible. Let me draw a better circle. There we go, that's a bit more like it. Now, is it still possible to work out this area here if I give it to you with 2 circles? Sorry, this circle is supposed to touch the end here. Have a go at it. Leave your thoughts and questions in the comments below. Like, comment, subscribe, and thank you for watching. If you found this video helpful or interesting, please hit the like button, let me know why in the comments below, and of course subscribe so you won't miss the next video. Thanks for watching, see you next time.